Okay, this is Chapter 10 homework. First problem 54 says, after scoring a touchdown, an 84-kilogram wide receiver celebrates by leaping 1.2 meters off of the ground. So 1.2 meters is the distance. We know there's a force involved that requires you to jump off the ground. The force that you're overcoming would be mass times acceleration, which in this case would be mass times gravity. And so how much work is done by the receiver in the celebration? Well, that would be 84 times 9.8 for this force. And we know that work equals force times distance, which is going to be, force is 84 times 9.8, and the distance is 1.2. So if you do that, you get 987.84, and units on that are joules. Next question says, a student librarian lifts a 2.2 kilogram book from the floor to a height of 1.25. So we're going to lift this book up to a height of 1.25 meters. And then we're going to carry the book 8 meters, and then we're going to bring it down to the shelf right here, which is only 0.35 meters above the ground. How much work does he do on the book? Okay, this is might be a little bit of a confusing problem, but the work that he does is equal to force times distance. So when he lifts the book up, that's the work that he does. Over here, gravity does work on the book to bring it back down. So we're only counting the work that he does, which is going to be the force of gravity that he overcomes, which is mg for the book, times the distance of 1.25 meters. So the mass of the book is 2.2 kilograms, gravity is 9.8, and that's the only work that he does to lift the book against gravity. Over here, gravity does work against him to bring the book down. So we're only counting this part right here. And obviously, we don't count the horizontal either, because the force that's being involved here is gravity, which acts straight down, and the distance that's being moved here is horizontal. We only use work equals force times distance when force and distance are in the same direction. So this is our answer for the first part. How much work does he do? 26.95 joules is our answer for work. Okay, and then it says how much work. Actually, that's the only answer we need to give here. This homework solutions are going to give you a different number, and I'll be more specific on a test about a question like this. But basically, gravity does work right here to bring the book down to here, so we have to subtract that amount. Or what you can do is just work equals force times distance again with the same force, but use this height that you use right here, 0.35, and that will give you the answer that is on the solution guide. So technically, he does work to lift the book up to here. Gravity does work against him, so the total amount of work that he does is actually only 0.35 right there, which gives us about 7.546 joules. All right, a wagon is pulled by a force of 38 newtons exerted on the handle at an angle of 42. So we've got a force pulling this way at a 42-degree angle. If the wagon is pulled in a circle with a radius of 25 meters, how much work is done? Okay, so now I'm going to draw like a bird's eye view as well. This thing gets pulled in a circle of radius 25 meters. Now, how much work is done? Well, that's force times the distance. We can figure out the distance by figuring out the circumference of the circle, but we do need just the force that pulls in the horizontal. So we just need this force here. In order to find that, this 38 Newton force, we're going to have to do 38 cosine of 42. That's the force along the horizontal, that's pulling this thing in the circle. So that's what we're going to use for force, 38 cosine of 42. Times the distance. Now the distance in this case is the circumference of the circle, which we know is pi times 2r, or 2 pi r. Now the radius in this case is 25. So if you plug that in and solve, you get, this is 4,435.9. And that's work, so our units there are joules. All right, the next problem says we have a 17 kilogram crate. It's pulled a distance of 20 meters, requiring 1,210 joules of work to be done. If the job is done by attaching a rope, pulling with a force of 75 newtons, at what angle is the rope being held? Well, we can work backwards with this work formula. We can do work equals force times distance to find the force that's there. Obviously, we plug in 20, so we have 1210 equals the force that's being applied. which would be the force in this direction, because we know our force in direction has to be the same, our force in distance has to be in the same direction. And the distance is 20. You can divide by 20, and that gives us the force in that direction, which is 60.5. And that's newtons. So this is 60.5. So basically we can make a right triangle here now and find this, this angle by doing adjacent over hypotenuse. So cosine of that angle has to equal adjacent over hypotenuse, and then do inverse cosine. So if we do inverse cosine, 60.5 divided by 75, that gives us 36.23 degrees. All right, the next problem gives us a tractor, weighs 120 kilograms shown here, and it's going up a 21 degree angle, and it's going to travel for 12 meters in 2.5 seconds. It wants us to calculate the power. Power equals work divided by time, and work equals force times distance. So here's our formula that we're going to use. Now the force that's overcoming is gravity. Gravity acts straight down, but only a portion of that gravity pulls back. So let me do this in different color. I can break this blue vector up into two other vectors, right? A vector pulling back in the x direction we'll call, and a vector pulling back in the y direction. And this blue one is the same as these two red ones. So I'll focus on the red ones then, because that's the force that we're overcoming, the force that's in the direction of the movement, or in the distance we travel. We have to use that for work. So to find that, this is going to be cosine of, this would be 69. So it would be cosine of 69 equals adjacent over hypotenuse. Multiply both sides by mg, and that's my force that I have to use. So power equals mg cosine of 69 times the distance that it travels, which is 12, divided by the time, which is 2.5 seconds. So we know the mass, we know gravity. The mass is, it gave us this 120, and gravity is 9.8. So plug those things in, solve for power, and that gives you 2022, about 0.9 watts. Okay, the next question says, Sulan has a mass of 52 kilograms. And she's riding on this escalator, the world's longest one, with an average angle of inclination of 31 degrees. And it says this thing is 227 meters long. How much work does the escalator do to lift her? Well, the force we know that work equals force times distance. So we just have to figure out the distance that she moves, which is this distance d right there in the vertical. Because the force, if we draw a free body diagram on her at any point, the force acts straight down, mg. So I'll use mg for the force for her, but then I need to find this distance. To do that, I'll do opposite over hypotenuse, so I'll call that d. So it would be the sine of 31 equals opposite over hypotenuse. Multiply both sides by 227, and then there's your d, 227 sine 31. And there's your answer. If you multiply this out, her mass was 52, gravity was 9.8, multiply that by 227, and then by the sine of 31, and that gives you your answer of 59,579.2 joules. Work is measured in joules. All right, the next problem says we're going to push this crate up a ramp. We're going to apply work equals force times distance. And once how much work is done, well, that's a force of 400 times the distance of 2, and that'd be 800 newtons. I'm sorry, joules. Now for part B, what if we lifted this crate straight up? Well, that would be that'd be mg times the distance of 1 meter. So the mass is 60 times 9.8, or 10, which gives us about 588 joules. Okay, the next problem here says a worker pushes a crate that weighs 93 newtons. The worker pushes horizontally parallel to the ground. The worker exerts force of 85 newtons. How much work does he do? Well, work equals force times distance. That one's pretty easy. That's just 85 newtons times the distance that it moves, which is 4. That would be 340. And then for B, How much work is done by gravity? Well, work equals force times distance. The force of gravity is mg, but they gave us that as 93 newtons times the distance that it moves, which is -3 because it's going, gravity's pulling down, this thing goes the other direction. So it actually does a negative 279 joules. All right, next problem gets a little tricky, very tricky actually. I need to find the force done by friction, which is work equals force times distance again, but this time it's the frictional force, which is just mu sub k times the normal force times distance again then, which is fine, except for what makes this problem so tough is the normal force. There's the weight of the block causing part of the normal force, but there's also the force that we're pushing is also pushing it against the ramp. There's two forces pushing against the ramp. We got to add those together to get the normal force. So I'm going to break this up into a triangle, like this, a right triangle. I'll just call this f sub x and f sub y. This is part of the normal force though, it's f sub y. I'm going to find it. I can find this, I need this angle first. This angle up here would be like inverse tangent of opposite over adjacent, so it'd be inverse tangent of 4 over 3, which gives us 53.1. That would be the angle right here. And then to find the normal force would be opposite over hypotenuse, where the hypotenuse is 93. So it would be sine of 53.1 equals opposite over hypotenuse, multiply both sides by 93. So there's part of the normal force, but I also need to find another part. So to find that other part, I'm going to have to get that from the force that I'm pushing with. So I'll break it up in a new triangle now. I guess this right triangle, or I guess it'd be easier to do it this way, because then I can see this angle is the same. So this angle down here would be 90 minus my 53.1, which is 36.9. So this angle is 36.9 down here and right here, corresponding angles. Now I'm going to do, I want the normal force, I want this part over here, I'll call it f sub y2, opposite over hypotenuse, so it'd be sine of 36.9 equals opposite f sub y2 over hypotenuse 85, multiply both sides by 85. So here's the two ones I have to add together. So it'd be 0.2 times these two added together, 93 sine of 53.1 plus 85 sine of 36.9 times the distance that you travel, which is 5. So there is, if I do that in my calculator, I should get about 125.4, and that would be joules. Okay, the next problem, last problem then, is we have a car driving on the road at constant speed. Constant speed is important because it tells us that the force that's resisting, we'll call that friction, and the force that's driving the car down the road are equal. Well, they tell us that power, they give us the power. We know that power equals work divided by time, which work is really force times distance. So if we find this force right here, that's going to be equal to the force that's slowing down, force of friction. So let's find that force. To do that, I have the power. I don't have the time though. So what I'm going to do is, I recognize that this is traveling at a constant velocity. Then I know that my distance equals velocity times time. So I can solve for t, dividing both sides by v. T equals d over v. So I'll make this d over v, and I'll multiply by the reciprocal instead, v over d. And the d's would cancel, and I get power equals force times my velocity in this case, which they give us. So I'm trying to find force, so I divide both sides by v. So force equals power over velocity. Power is 48 kilowatts, so that's 48,000 watts. I need to be in watts. And my velocity needs to be in meters per second. So I'm going to have to take this 76 kilometers, which is 76,000 meters, divided by hours, and multiply by 3,600 seconds are in 1 hour, or rather divide by 3,600. That gives me 21.1 meters per second, 21.1 repeating, and that gives me a force of about 2,273.7 newtons. And we know if we're in the right units, we should have newtons here.